Hello, I'm Mr. Bennett, and I'm back with you again to help you to understand how to subtract signed integers. Let's look at our first example. We're going to use our same tile layout that we used in our adding integers in the previous lesson to understand how to subtract integers. We're going to start with a very straightforward problem, 6 minus 2. So, here's our positive 6. Now the most straightforward way to do this obviously would be to simply take away 2 positive tiles. But I'm going to show you a technique that might work even if you don't have the tiles that you want to take away. We could, in order to get rid of these 2 tiles, we could add negative 2. And we actually get the expression 6 plus negative 2, and then these would cancel out the 2 tiles that we wanted taken away, and we get 4 positive tiles, or plus 4. So what we've just shown is that 6 minus 2 is really the same thing as 6 plus negative 2. In either case, we got 4. This can be somewhat helpful when we have an expression like 3 minus 5. Let's look at that on our tile board. Here's our plus 3 shown on our tile board. How are we going to take 5 tiles away when we only have 3? Well, here's one thing that we can do. Think about that expression, and instead of being 3 minus 5, think of it as 3 plus negative 5. So instead of taking away 5, we're going to try to add 5 negatives. 1, 2, 3, 4, 5. So 3 subtract 5 becomes 3 plus negative 5. What happens is when we combine these tiles, as we would if it was addition, is we get negative 2. So 3 minus 5 is the same as 3 plus negative 5. And if you think back to our rules of addition, remember that if you add 2 numbers with opposite signs, you actually take the difference of their absolute values, which is 5 minus 3. That leaves us 2. And then because 5 had the larger absolute value, our answer is going to be negative 2. This same process can work for any type of problem where you need to subtract integers. Let's look at the problem negative 4 minus 2. Now really what we're going to lay out on our integer board is negative 4, subtraction to plus, and we're going to add negative 2 tiles. So let's see what that would look like. So here's our negative 4. Now really we can't take away 2 because we don't have 2 positive tiles to get rid of. So this is why we need to think of this as negative 4 plus negative 2. Because while I can't take away 2 positive tiles, I can add 2 negative tiles to get negative 6. So negative 4 minus 2 is the same thing as negative 4 plus negative 2, which does give me, by the rules of addition, same signs, find their sum, that's 6, and the larger absolute value is on the negative 4, so it's a negative 6. So negative 4 minus 2 is negative 6. Let's do a similar problem. Let's start with a positive integer, positive 6, and we're going to subtract a negative 3. Now when we look at our integer board, we're probably going to notice that we can't really take away negative 3 tiles. Let's take a look at that. So here we go. Here's our positive 6. Is there any way to take away 3 negative tiles? No. So what we're going to do instead is we're going to try to add positive tiles. So we're going to add positive 3 tiles. And notice that we get 9 tiles in total. So 6 minus negative 3 is the same thing as 6 plus 3, which turns out to be positive 9. So to subtract signed numbers, you add the opposite. Some of you might have heard this before as keep, change, change. Because remember what we did was we kept the first integer just as it was. We changed the subtraction into addition, and then we changed the sign on the second number. If it was positive, we changed it to negative. If it was already negative, we changed it to positive. So now let's try this example. 18 minus negative 7. Well, we're going to keep the first number. We're going to change the problem to addition. And then we're going to change the sign on the second number. The negative 7 will become a positive 7. And then we're going to follow the rules for addition. We have two numbers with the same sign, so we add them. And the answer takes the sign of the larger absolute value. 18 has the larger absolute value, so our answer is positive. Here's another one. Negative 15 subtract negative 4. So again, we're going to add the opposite. So this equals keep the negative 15, change the subtraction to addition, and change the negative 4 to a positive 4. Now we're going to follow the rules for addition. We have different signs, so we find the difference of the two numbers. 15 and 4 have a difference of 11. Now, we need to figure out which sign. The negative 15 has the larger absolute value, so our answer will also be negative. Here's another example. 25 subtract 18. Now, if we follow our rules for subtraction, that would be equal to 25, change the subtraction to addition, and that's a subtract 18, so we need to change that 18 to a negative 18. And then we follow the rules for addition. Well, we need to find the difference between 25 and 18. Well, that's 7. And then since the 25 has a larger absolute value, it would be a positive 7. Now you may recognize from this that that's just basically the same thing as 25 subtract 18. And when the two numbers that you're subtracting are both positive, it's often easier to just go ahead and do it the way you're used to doing it, and do 25 minus 18. You'll eventually be doing that anyway. But as you can see, we could also do it by following the rules for keep, change, change. Here's another example. 34 minus 54. Now again, we do keep, change, change. We get 34. Subtraction becomes addition. That's a positive 54, so we make it a negative 54. And now again, we have two numbers with different signs, so we find the difference. The difference of 54 and 34 is 20. And since negative 54 has the larger absolute value, our answer is negative 20. Now again, notice that you basically ended up subtracting 54 and 34. So subtraction, again, with two positive numbers is basically the old subtraction that we're used to. In this case, we get a negative answer because we took a larger number away from a smaller number. So we didn't necessarily have to use keep, change, change in this case, but it did perhaps make the problem a little easier for some. Our last example is negative 72 minus 8. Now, because you've got a positive and a negative integer in this subtraction, it may be a little hard to figure out whether you should do a sum or a difference. Since there's a negative number involved in this subtraction, it's probably best for you to apply the keep, change, change rule. So we're going to keep the negative 72. We're going to change the subtraction to addition. And now that's a positive 8, so we need to change it to a negative 8. Now we can see by the rules of addition that the numbers have the same sign. So we find the sum of 72 and 8 is 80. And Because negative 72 has the larger absolute value, we'll call that negative 80. So, to review, to subtract signed numbers, you simply add the opposite. That is, you keep, change, change. Keep the first integer, change the subtraction to addition, and change the sign on the second integer. Then you can simply follow the rules for adding. It's especially important to remember these rules if either of the numbers involved in the subtraction is negative.